So let's now go to 6.2. We're talking about transforming and combining random variables, okay? So we've kind of done this stuff before. So we're going to transform. So if you go to page 382, there's a transforming a random variable. It says, in chapter 2, we studied the effects of the transformations in the shape center and the variability of quantitative data, okay? And we discovered that, so this is in chapter 2, we found that when you add, or for that matter, subtract from the measure of center, okay, when you add or subtract a constant, you're going to add or subtract that from the measure of the standard deviation stays the same. So the range stays the same, the IQR stays the same, shape of the distribution does not change either, okay? When you multiplied or divided by a constant, we found that the measure of center, whatever it is that you're talking about, would be multiplied or divided by. Also the variability, so the standard deviation, the IQR, the ranges, also are now multiplied or divided by the same number. But again, the shape of the distribution does not change, okay? And if you look at the random variables, you're going to get exactly the same analogous, same effect. So if you go to the bottom of page 383, it says the effect of adding or subtracting a constant on the probability distribution. Okay, notice that the probability distribution itself does not change, okay? That does not change. The probability for each of the things do not change. Okay, you're only adding or subtracting to each variable. The number, so let's go back to, we had the 300, 450, 600, 750, 900, and then you had the variable, what was the probabilities for these were, I must have went too far. Well, not far enough. Here we go, we had 0.15, we had 0.25, 0.35, 0.05. And we have 0.20. So you're only changing the top line here. The probability distribution, the probabilities themselves are going to stay the same. Okay, so when you add, let's say you added 100 to each of them. So we're going to be, instead of 300, it's going to be 400, 550, 700, 850, and 1,000. Okay, then you would just add that 100 to the mean, but the standard deviation is going to stay the same. The shape's going to stay the same. The probability distribution itself is going to be the same, okay? And that's all down there in the bottom of page 383, okay? Now, on the flip side is that if you go to page 385, when you multiply, okay, you're going to multiply, if you multiply or divide each number to the random variable, again, you multiply or divide the mu, okay, because that's going to change accordingly with that. The standard deviation also changes, which means that the IQR changes and all that other stuff changes, okay? But the shape, again, does not change. The probability distribution itself does not change, okay? All right, so that's that, really. Let's do a couple of examples, and then we'll call it a day. So let's go to example. So example number 385. On page 385, there's an example that says, how much does college cost? Okay, how much does college cost? All right, it says, El Dorado Community College considers a student to be a full-time student if he or she is taking between 12 to 18 units. The number of units X that a randomly selected El Dorado Community College is taking in fall semester has the following distribution. okay? So, 12, 13, 14, 15, 16, 17, 18, okay? And if you go ahead and do the histogram, it looks like that. Okay, and right is a histogram of the probability distribution. The mean is 14.65 and a standard deviation is 2.056. At El Dorado Community College, the tuition for full-time students is $50 per unit. That is, if tuition charge, if T is equal to tuition charge for a randomly selected full-time student, T is equal to 50x. A, what shape does the probability distribution of T have? Okay, so the probability distribution, since we had 12, 13, 14, 15, 16, 17, and 18, and we had 0.25, 0.15, 0.05, 0.30, 0.16 was 0.10, 17 was 0.05, 18 was 0.15. Okay, so let's first of all add these together. I get 0.45, 0.75, 0.85. What? So it's like they add to 1, right? They should add to 1. Okay, all right, that's good. Oh, this is 0.10. That's what's okay. So let's add them together, 0.35, 40, 70, 80. All right, we're good. So now if we add this, so we're going to call the T, the distribution of T. T is nothing more than this guy times 50, right? So you're going to have T. So this is going to be 650, 750, 800, 850, 900, because you're multiplying this guy times 50, right? Okay. So A, what shape of the probability distribution stays the same? Nothing changes there, right? B, find the mean of T, the mean of T. Since the mean of this guy, the mean was what? We were told that was 14.65, 14.65. Then the mean of T, since I multiplied it by 50, is nothing more than 50 times 14.65. 50 times 14.65. Right? And then we have calculate the standard deviation of T. The standard deviation of the original one was 2.056. So sigma is going to be 50 times 2.056. Okay, nothing more than the multiplication because you multiplied it by 50, right? Okay, so that's simple enough. Let's go to page 387 and talk about the baby and the bathwater. Let's see the baby and the bathwater. Everybody read it on your own. I'm not going to read it out loud, so read it while I am erasing the board. Okay, so we had the Fahrenheit, so we know that the Fahrenheit is equal to that. So Fahrenheit is equal to 9/5 plus 32, okay? So the mean was what? The mean was 34 standard deviation, so the mean was 34 degrees Celsius. Standard deviation was 2 degrees Celsius. And we need to find the mean of y. So the mean of this guy. So the mean of this guy is going to be what? Mean of this guy, since I multiplied it by this, I'm going to do the same thing, right? I'm going to do times 9/5. Then we're going to add the 32. Okay? So what do we have? We're going to get, if we do that, we get 93.2. 93.2 is going to be the new mean in Fahrenheit. Okay. And then B, calculate and interpret the standard deviation. The standard deviation, okay? So when I do this, the standard deviation is going to change. So I'm going to be the standard deviation of F is going to be equal to 2 times 9/5. But when I add the 32, that does not change the standard deviation, right? Because when I add, the standard deviation stays the same, it's unchanged. So all I'm doing is just this. So I'm going to get 18/5, which is 3.6. And so there you go. That's that. Okay? So again, in conclusion, when we add or subtract a number, the mean gets added or subtracted, the standard deviation or the IQR, the range, all stay the same. The probability distribution stays the same. The shape stays the same. When you multiply or divide by a number, the mean and the standard deviation, IQR, all these things are multiplied or divided by. The shape stays the same. The probability distribution stays the same. Okay? So with that,